Okay, so in this video today we are going to introduce polynomials, and the main essential question for today is I can identify, evaluate, add, and subtract polynomial expressions. So the first question you might have is, what is a polynomial? Well, I kind of got to define here. It's really hard to tell you what a polynomial is, but I'm going to try to give you examples, and maybe that will kind of clear up what a polynomial is. Here's kind of a definition though. A polynomial is a monomial, and we'll talk about what a monomial is soon, or the sum or difference, okay, so the addition or subtraction of monomials. Each monomial is called a term of the polynomial. So polynomials and many monomials make it up through addition and subtraction, and they're divided into terms. So what is a monomial? Well, let's look at what is and what isn't a monomial, and then we'll use that to figure out what polynomials are. Well, first we have x is an example of a monomial right here. This is a monomial, and 9 is also a monomial. 9x, actually, if you multiply 9 times x, that's a monomial as well. 9x to the third power is a monomial, and even if you have a decimal in there, 0.9x to the third power, those are all monomials. Okay, so what isn't a monomial? Well, here's some examples of things that aren't. I'll try to explain why. This first one is 1 over x. 1 over x, like this, sadly isn't a monomial because x is in the denominator, thus making it not a monomial. And here we got the square root of x. This is not a monomial either because x is raised really to the 1/2 power in this situation, and if you have a power that's not a whole number or not a positive number, it's not a monomial. Here we got 2 to the x power. That's not a monomial because our x is in the exponent. Our variable is in the exponent, 2 to the x. We can't have that up there. And here we got 2 to the x to the negative 2. Well, because it's a negative 2, thus making it not a monomial. In fact, if you were to take this, it would flip it to the bottom, just like this first example right here. They're very similar. So let's take these ideas of what a monomial is and isn't and figure out which one of these over here are polynomials. Well, let's look at this first one. We have 2 divided by x plus 2. Well, in this situation, the x is in the denominator, and we know it can't be in the denominator, thus making this not a polynomial. Let's look at this one, this e to the x. Is that a polynomial? Well, we got an x in the exponent. That can't be, we can't have that, so thus that is not a polynomial. Let's take a look at this one, this 3xy to the negative 2. Well, sadly, this negative 2 right here makes this not a polynomial because it's a negative exponent, thus making this not a polynomial. Cross that one off. Well, let's go over here. We got negative 6y squared minus 7/9 x. Is there anything there keeping it from being polynomial? Everything looks fine. There's no x in the denominator. There's no negative exponent. We don't have any negative or irrational or rational exponents. So this does look like to be a polynomial. Let's take a look at the square root of x. Well, we have a very similar example over here. Our x is to the 1/2 power, thus making this not a monomial. So this isn't a polynomial. Let's look at this bottom one. We've got to look at each of these terms down here. Do any of these terms have an exponent in the, or a variable in the exponent, or a negative exponent, or what else? What else? Let's go. An exponent with a fraction in it. I don't see those in any of these. So this would actually be a polynomial. And that's how you determine if it's a polynomial or not.